Hello my dear students, welcome back to the chemistry class. The chapter is some basic concepts of chemistry, and from this chapter we have seen some of the basic concepts, isn't it, in the previous class. That is one mole concept, the different formulae which are there to calculate moles. Fine? Yes. Do you remember this? Yes, of course you have to. Okay, fine. Then empirical formula and molecular formula, that part we have seen. How to relate molecular formula with the empirical formula. It is a factor n integer to be considered, isn't it? Yes. Next, we have also seen stoichiometry to some extent, isn't it? When a balanced chemical equation is given, what are the information we can get from this? Remember, water example we have taken, hydrogen and oxygen combining to give water. So when you balance that equation, what mass of hydrogen and oxygen are going to get consumed to produce a definite amount of water? Are you getting, dear students? This was the equation, I suppose. H2 plus O2 giving 2H2O. Okay, I'll remove that backward sign. Okay, this is the equation. So when you balance it, you will get 2H2. 4 grams of hydrogen will combine with 32 grams of oxygen to form 2 into 18, that is 36 grams of water. That was the first inference or information we can get from the balanced chemical equation. Then we also said that 2 moles of hydrogen will consume 1 mole of oxygen to form 2 moles of water. Then in terms of volume also we can relate, isn't it? Molar volume concept. So 1 mole is equivalent to 22.4 liters, or in terms of milliliter it is 22,400 ml. So that part also we have seen, very important. So in today's class, let us continue from here, that is the stoichiometric calculation. Most of the chemical reactions, or almost all I can say, will be carried in the, or is taking place in a molar ratio. Okay, in terms of moles it is not in terms of mass. But usual practice, what we do is we weigh a certain amount of, okay, the reactant, and we'll put for the reaction, that is in a reactor. Now, there is no guarantee that the weighed amount will contain exact number of moles. I'm slowly entering into the today's concept. Okay, so there is no guarantee that the weighed amount will contain the required number of moles. So with that, what happens, you tell me? One will be present in large amount, one of the reactant I'm talking about, the other will be in the smaller amount or lesser amount, I can say. So with this, a reaction is going to get stopped at one particular stage where out of 2, any one of the reactant got consumed completely or entirely. Are you getting this situation scenario? We have 2 reactant, and to form product, both the reactant should be present. But as the reaction continues or progresses, what happens? One of the reactant, since it is present in a lesser amount, is going to get consumed completely. So with that, what happens? Reaction is going to stop. Are you understanding? Yes. So the entire product formation, that is water here in this example, is controlled by which of the 2 reactant, you tell me? Unless it is present in equal amount, any one of the reactant which is present in smaller or lesser amount is going to stop the reaction at one particular stage. Do you agree? Yes, you have to. Why? Because it is a fact, isn't it? Yes. So that reactant which is present in very small amount, or out of 2, very small when I say, since it controls the reaction, we can say it limits the reactant. Or reaction, I'm sorry, okay, which limits the reaction. Now that reactant which limits a chemical reaction is said to be limiting reactant or limiting reagent. So both the terms are in use. So what is a limiting reactant, dear students? Yes, a reactant which is present in lesser amount gets consumed completely during a chemical reaction, thereby chemical reaction stops. This is known as limiting reactant. So what name can be given for the other reactant? Either of these 2. What name can be given? Excess reagent. So 2 terms should be remembered. One is limiting reactant, the other one is excess reactant. So it is a continuation of your stoichiometry, dear students. So from this section or in this chapter, the one question you can now expect to the maximum extent is limiting reactant type question, because it includes stoichiometry as well as the next level of it. It is limiting. Is that okay? So the next concept to be studied is limiting reactant. I'll write it here. Okay. So it is limiting reagent, or it is also known as reactant. Point to be noted down. Okay. So limiting reagent. I already explained what it is. Reagent which is present in smaller or lesser amount which limit the chemical reaction is said to be limiting reactant. Now, as long as we proceed according to the mole ratio, that is 2 moles of hydrogen and 1 mole of oxygen is taken, we don't have this particular condition or this situation at all, because we are taking exactly required number of moles. But then in practice, as I said earlier, we are taking in terms of grams, that is mass of a reactant. Now, mass and mole, how they are related, you know it. In the previous class we studied it, isn't it? Mass and moles related through molar mass. So we have written that formula, N is equal to M divided by M. So since we are taking in mass, right, the reactant, so you have to multiply, or to get mole you have to divide it by molar mass, or to get mass you have to multiply number of moles by mass, that is molar mass. So in this way these are related. So most of the times, or almost all the times in problem, numerical, what the question paper will contain is amount of hydrogen and oxygen in the form of mass. Is that okay? So we need to convert that either into moles or the cross multiplication method which we are going to study today. Is that fine? So one problem, let us discuss about it. Okay, how to carry out this type of, or how to get the solution for these type of problems. So first problem will be, same example I'll continue. Imagine in the question paper you get a question like this: 4 gram of hydrogen and 12 gram of oxygen or 16 grams of oxygen are taken in a closed vessel to form water. Calculate the maximum amount of water formed. I repeat the question: 4 grams of hydrogen and 16 grams of oxygen were taken in a closed container to get a water. Calculate the maximum amount of water formed. The students, whenever masses are involved in a stoichiometric calculation, you have to proceed through this limiting reactant concept. Okay, there is no other way. You can't directly calculate it all, because we never know whether the taken amount is equal to the molar ratio. Okay, it's fine. So what we have to do? Initial step, or the first reaction is, whenever such type of question is given, write the balanced chemical equation. Is that okay? Next, you write the standard condition. What do you mean by standard condition? According to the balanced chemical equation, you know what is the molar mass of the given reactant. You're supposed to know it. Okay, then you write the condition. So standard condition is that 2 into, say, H2 molar mass is 2 gram. So 2 into 2 is 4 gram. So this is a given data. What I'll do is I'll write bit down below here. Okay, so 4 gram and 16 gram. What is the water formed is a question. Now what you do here is 2 into 2 gram. Why it's 2 gram? Because hydrogen molar mass is 2 gram. So 2 into 2, 4 gram of hydrogen in the equation consume, right, will consume how much? O2. Oxygen 16 gram is atomic mass. O2 is 32 gram of oxygen to get, or to form 2 into 18 gram of water. Are you understanding? So according to the given information, that is with respect to the reaction, you require 4 gram of hydrogen. For that, 32 gram of oxygen will be consumed to form a complete product. Now you just check it out. Here in the given data, though hydrogen appears to be very less compared to 16 gram, which will be the limiting reactant? Let us understand in this way. 4 gram requires 32 gram according to the equation, but we are having only 16 gram. Isn't it half of it? Are you understanding, dear students? Yes. So which out of 2 reactant, which of these 2 is present in lesser extent or lesser amount? Isn't it oxygen? So once all 16 gram of oxygen gets consumed, reaction will be stopped. So we have excess of hydrogen. How to prove it methodically? Yes, what you do is you take any one of the reactant given in the question. So I'll take 4 gram. okay, hydrogen, or you can go for 16 gram. What I'll do is, after writing the standard data, what I'll do is 4 gram of hydrogen requires how many grams of oxygen. Let me calculate first, later we can go for product. Why? Because product formed is entirely depending on the limiting reactant. So our first work in these types of problems to calculate which one is the limiting reactant. Or you can go for another way, which one will be the excess reagent, that also can be calculated, because one, if it is excess, the other has to be limiting in the case of two reactants reaction. Hope you are getting, dear students. Yes, so I have 4 gram of hydrogen. How many grams of oxygen is required for this? You can cross multiply and obviously you'll get it. 4 gram 32. Since we are having 16 gram, half of it, this is the limiting reactant. Or you go for cross multiplication, so you'll get 4 into 32 divided by 4 will be 32 gram, but we are having only 16 gram. Therefore, our oxygen is a limiting reactant in this particular data. So the entire product is formed depending on oxygen, because once oxygen gets consumed, reaction stops. So product is related to the limiting reactant. So the question to be answered in this way, this implies that LR stands for limiting reactant is oxygen, O2. Therefore, let me write O2 on side and H2 on the other side. Now O2 is 32 gram according to the standard condition. Okay, if it is so, we'll get 36 gram of water. Now we are having only 16 gram of it. How much water is formed? So cross multiply. Are you understanding? So it is 32 gives 36 grams, 16 grams gives how much? So what I'll do, this implies that 36 into 16 divided by 32. So 16 ones are, 16 twos are, it is nothing but 18 grams of water is formed. So this is a very, very important type of problem, dear students. Okay, so what I'll do is I'll give one exercise for you. I expect answer from your side. Okay, so the exercise is this. In a given chemical reaction for the formation of ammonia, so what is the ammonia formation reaction? N2 plus 3 moles of hydrogen, okay, giving 2 moles of ammonia, NH3. The amount of nitrogen and hydrogen taken are respectively 50 kg and 10 kg. Okay, so we are taking 50 kg of nitrogen and 10 kg of ammonia. This is a very famous method of process, dear students, which is known as Haber's process, industrial method to prepare ammonia. Okay, now 50 kg of nitrogen and 10 kg of hydrogen was taken in a closed vessel, of course, and we carried out a reaction to get ammonia. What is the maximum amount of ammonia formed under these conditions? Okay, what is the maximum amount of ammonia formed? So whenever maximum amount is formed or asked, you supposed to find out the limiting reactant, then proceed according to the limiting reactant. Will you do this? Yes. Hint is that equation is given and you supposed to know the atomic masses. So as a beginner, if you don't know, let me give it. Nitrogen atomic mass is 14. So molecular form it is, therefore 28 grams. Standard condition I'm writing here. See here we have written 4 and 32. No? In the same way here 28 gram consumes 6 grams of hydrogen. 3 into 2, 6 grams. So that is your standard condition. What is the amount of product formed under that condition? 2 into 14 plus 3, 17, 34 gram of ammonia. So one side you have standard 28, here 6 grams, here 34 grams. Now find out, if we take in this ratio, what is the maximum amount of ammonia formed? Will you do this? Yes, you can. Okay, or you have to, you will be definitely fine. So moving ahead, after limiting reagent concept, we have reaction in solution. So this is the last part of your basic concepts of chemistry, but very vast it is. Okay, let us understand that. It is, what is that concept? It is reactions in solutions. So I'll write it here. Reactions in solutions. Yes, if you go for finding out the significance of this statement or this side heading, almost all the chemical reactions will be taking place in a better way in liquid state, that is in solution. So what we do is, whenever we carry out reactions, most importantly ionic reactions, we will be doing it in solution, because ions are produced only when you dissolve, okay, or when you add liquid to that is a solvent we call. Now most of the times solvent is water, so we call aqueous solution. Fine. So reaction will tend to fast, even though certain reaction will be carried out or is carrying out in a solid state, the reaction will be faster, more better in liquid. So therefore we call the reactions in solution, which is a very, very important point. Now whenever we talk about reaction solution, the most observable property, I repeat it, most observable property is concentration. Okay, so what do you mean by concentration? Amount of solute present in a given volume of solvent is called as concentration. There are a lot of units to express concentration. Few of them we are studying in this concept or under this concept. Okay, so concentration is nothing but how much or how many grams of solute you have added to a definite volume of solvent. So that is your concentration. It will be expressed in different ways. Here 4 different ways we will be studying. First one is molarity, second one is molality, third one is mole fraction, and last one is normality. Okay, that normality is not included in your NCERT, but there are a lot of instances where you got the questions from the normality in competitive examination. For board exam, anyway it is NCERT. Okay, so we'll be studying these 4 units. Apart from that, 4 terms, apart from that, one extra is there, that is mass percentage. Okay, how a concentration can be expressed in terms of mass percentage. Are you understanding, dear students? Yes? Fine. So let us study one by one. First one, let me talk about mass percentage, which is a small concept. Okay, so first of the units to express concentration, that is whenever reaction carried out in a solution, is mass percentage. Mass percentage. Okay, so or weight percentage it could be. So the unit or short form to represent is W by W, which is nothing mass by mass. So whenever we say mass percentage, we should remember the formula, that is mass percentage is equal to, okay, mass percentage is equal to mass of the solute. Okay, mass of the solute divided by mass of the solution. Mass of the solute divided by mass of the solution. Since percentage it is, we should take 100. So this ratio, that is solute to this solution ratio in 100 gram, we call mass percentage. Okay, hope you can do this problem if it is given. How? One example, if you want, let us talk about, okay, mass percentage calculation, how it goes. Imagine, okay, 4 gram of urea is dissolved in 60 gram of solution or 60 gram of the water. What is the mass percentage of urea? I repeat, 4 grams of urea dissolved in 60 gram of water. Calculate the mass percentage. Can't you do this? Yes. How? Solute is urea, so 4 divided by 60. So simple it is, right? So 1 by 15 into 100. So that will be the mass percentage of urea. So very simple unit to express the concentration. The second one, which is more important though, it is molarity. Okay, so very important, molarity, denoted by capital letter M. What is molarity? It is also unit of concentration. How to write molarity expression or formula? So let me write it. Molarity M is equal to number of moles of solute, number of moles of what? Solute. Okay, divided by number of moles of solute divided by volume of solution in liter. Volume of solution in liters. Capital L I have written for liter. Is that okay? So how many moles of solute present in liter of a solution is going to be the molarity. Is that okay? Molarity. Now, number of moles as such we cannot calculate, but we know the formula, so I can put this in short form as N, number of moles, and volume in liter VL. Is that okay? So which is your capital M, that is molarity. The shortest formula to remember. Having said that, number of moles in most of the problems won't be given, but mass will be given. So we know how to convert mass into mole, isn't it? What we supposed to do, dear students? Number of moles equal to mass by molar mass. So what we do here is this N, let us substitute, that is mass in grams divided by molar mass. Molar mass into what? Volume of solution in liters. So this is your expanded formula, okay, to calculate the molarity. Very important. Remember, it is important till your second PU final competitive examination. Okay, it could be JEE or NEET. Such an important formula which will come in almost all physical chemistry chapters. Okay, so molarity is equal to mass divided by molar mass into volume. That volume should be in liter. Suppose if volume is in milliliter, what we are supposed to do? We need to divide by 1000, so that will come to the numerator. So one more formula or one more way of expressing it, molarity M is equal to 1000 into mass divided by molar mass into what? Volume in ml, milliliter. Because conversion 1 liter equal to 1000 ml, so that in ml if you write, then you have to divide by 1000, so that will come to the numerator. Okay, so therefore 1000 m into molar mass into volume in ml. Very, very important formula, let me tell you that. Is that okay? Fine. So one example, if you want to understand that concept, here is an example. The example is preparation of sodium hydroxide solution. Okay, so let me give that. 4 gram of sodium hydroxide is dissolved in 250 ml of a solution. Okay, or to prepare 4 gram or 250 ml of a solution, I'm sorry, let me put in that way, 4 gram of or 4.0 gram of NaOH is dissolved in water to prepare how many ml? 250 ml of solution Yes, example it is. Calculate the molarity. Okay, calculate the molarity. Calculate the molarity. Such a simple one. As a beginner, let us understand this. Calculate the molarity. What we are supposed to do, as I said earlier, apply to the formula directly. So molarity is equal to, I have given the second one here, isn't it? So this is it. So see, because it is in ml, milliliter, so we can go for that directly. 1000 into mass, is it given? Yes, 4 gram divided by, what is the molar mass of NaOH? Sodium, atomic mass 23, hydrogen 16, and sorry, oxygen 16, hydrogen 1 gram. So totally 23 plus 16, 39 plus 140. 40 into, they have told it is 250 ml of solution, 250. So 250 ones are 250 fours are, do you agree? 4 ones are 4 tens are, am I right? Next 2 twos are 2 fives are. So 2 by 5 it is. 2 by 5 is nothing but point, right? 5 4 is 24 molar. So the concentration of the solution or molarity of the solution is 0.4. Is that okay? So very important type of problem again. This one is a direct one. What the other question you can expect from this is like this. The second one. See, I'm working out the example as well, because to understand the concept in a better way, we need to learn along with the exercise. Okay? Fine. So the other problem is like this. It is, let us calculate the mass of substance present. What I am focusing here is this. Okay, mass of a substance dissolved in a particular solution. So you take down how many moles of or grams of HCl is present in 250 ml of, okay, 0.5 molar HCl. Calculate. So example 2, it is one more example I am talking about. Calculate the mass of HCl present in 250 ml. Okay, let me change. 500 ml. 500 ml of 0.25 molar HCl. Okay. We are supposed to calculate how many grams of HCl we have dissolved it in 500 ml of this molarity solution, that is 0.25. Shall we go for it? What we suppose, see, rearranging the formula, that's all. M is asked now here in this case. So let us write molarity is equal to 1000 into mass is asked, right, divided by molar mass of HCl, hydrogen 1, chlorine 35.5. So that will make this molar mass as 36.5. 1 plus 35.5 which is equal to 36.5 grams. Is that okay? Into volume 500 ml. Now molarity is given. How much it is? 0.25. I am not writing formula, dear students, directly, okay, to reduce the steps. Fine. So now what is the molarity? Sorry, what is the mass then? It is M is equal to, multiply it, 36.5 into 500 into 0.25 divided by, yes, it is divided by 1000. So 500 ones are 500 twos are, isn't it? So 36.5 into how much it is? 2.5, sorry, 0.25 into 0.25 divided by 2. So that is your 4 point, approximately I am writing 4.56 gram. What is the conclusion then? When we dissolved 4.56 gram of HCl in 500 ml of water, we will get a concentration as 0.25 molar. If you want, you can cross verify this. So this is how molarity problems to be dealt. And last concept under molarity is molarity equation. Okay, molarity equation. Yes, what is that molarity equation? When two different reactants are taken, of course, in a chemical reaction, how the molarity of those two can be connected, that part is dealt with respect to this formula. M1V1 is equal to M2V2. M2V2, provided one molar ratio is 1. Okay, now most of the times molar ratio won't be 1, so what we supposed to do is divided by N1 and here also divide by N2, respective number of moles or stoichiometric coefficients to be divided. Yeah, let me write. It is equal to M2V2 divided by N2. So what are N1 and N2? Stoichiometric coefficients of respective reactant. M1 and M2 are molarities of first and second reactant. V1 and V2 are the respective volumes. So through this equation we can find out M2, provided we know M1 and V1. Of course V2 will be given. So any one unknown can be calculated with this particular formula. Important one. Let us talk more about this in second PUC solution chapter, where we need to work out many problems based on this. So for time being, from this chapter, since it's basic concepts, let us understand the formula. That's enough. Okay, calculation will be in the next year. Anyway, so therefore that is about the second unit of concentration, molarity. Yes, the third one, let us move on. The third unit is molality. A small change, dear students. Okay, molality. So molarity we have seen. What is that molality? Let us understand. So you have molality, and the notation used for this is small letter m. Okay, it is small letter m, molality. Now how to write a formula for molality? Molality is equal to molality m is equal to, again it is same, number of moles of the solute, so n divided by mass of solvent in kg. In the earlier formula we took mass of solution, volume of solution, not mass, volume of solution. Now here we supposed to take mass of solvent, so let me denote it as W, kg, in kg. There it was in liter, now here it is in kg. So n by W kg is your molality, or we can write this as m is equal to, how to write n? We know it, mass divided by molar mass into W kg, or that can be converted, because in problems it will be given in the form of grams, so we can write it. How to write kg in grams? 1000 grams, isn't it? So therefore I can write it as 1000 times the mass of solute divided by S molar mass into weight of substance in grams, which is the molality. Again, very important formula. Okay, so you can expect questions either from molality or from molarity, so please do remember that. So weight of solvent will be given, you convert that into kg if it is given in gram, or directly apply formula 1000 into mass, so that can, or that will be done with a problem. Is that okay? Do you require example for that? Yes, please take down one problem on that. Hope you are getting, dear students. So important basic concepts we are learning now. Let me give a problem related to that. Calculate the molality of solution. Example, calculate the molality of a solution prepared by dissolving prepared by dissolving 5.3 gram of, let me take that, okay, 5.3 gram of sodium carbonate, 5.3 gram of Na2CO3, of course anhydrous, that without water, okay, anhydrous sodium carbonate in 250 ml, sorry, in 400 ml of water. So water is a solvent and they have given it is 400 ml. Fine. So shall we go for it? What is the formula? Molality is equal to, see, mass of solvent we require, but mass, its volume is given. We know that for water, density is equal to mass by volume. For water, density is equal to 1. Okay, so water density is 1. Therefore, don't you think, dear students, mass is equal to volume? So what is the mass? M is equal to V, that is equal to 400 ml. And we know that 400 ml is equal to 400 grams. So therefore, mass is given now. So let me put that. 4000 into mass 5.3 gram. Okay. Then molar mass of Na2CO3, sodium 23 into 2, 46. Is that okay? Plus carbon 12. Plus oxygen 16 into 3, 48. 48 plus 12 is 60 plus 46 is 106. Okay, into it is 400. Is that fine? Yes. So you cancel those two zeros. So 10 into 5.3 is 53. 53 divided by 106 into 4. 53 ones are 53 twos are. It is nothing but 1 by 8. 1 by 8, you know, point. Yes, 125 molal is the answer. Is that right? So 0.125 molal solution will be prepared by dissolving this. This is about the molality. Now, two more concepts to be taken, dear students. Let us do that. The first one is, or the next one, rather it is third, I suppose, isn't it? So third one is mole fraction. I'll take up normality at the end. Okay. So mole fraction. This is also one of the very important unit. Mole fraction. Yes. Next one is mole fraction, denoted as X. Fine. What is mole fraction? Whenever a solution is there, minimum two components should be there. Do you agree? Yes, one is solute, the other one is solvent. So this two component system we can call. Having said that, there is absolutely no problem if we have more than two components. A solvent is only one, but solute can be, or it could be 2 or 3, etc. So depending on that, mole fraction can be defined. So now imagine we have a two component system. One is solute, the other one is solvent. So let me write solute as A, solvent as B. Okay, two component system. Now what is mole fraction? Fraction, you know, it's a ratio. So how many grams of A, or how many mole no it is. So let us understand this in terms of mole itself. So how many moles of A present in total moles of the solution, that will be your mole fraction. So what I'll do, I'll write a formula. XA, that stands for mole fraction of A, is equal to number of moles of A divided by total number of moles of the solution, that is nothing but Na plus Nb. Did you get that? So this will give you the mole fraction. What about then XB? Mole fraction of B is equal to number of moles of B divided by total number of moles Na plus Nb. So very simple plus important formula. Now dear students, don't think that the number of moles will be given in the question. They won't give. What they told, or what they'll give, is mass, and it is next up to us to find out the mole fraction. Now one more point to be remembered is sum of the mole fractions of all the components in a solution should be equal to 1. Fraction value cannot go beyond 1. This point has to be noted down. XA plus XB equal to 1, or if it is 3 component system, XA plus XB plus XC is also equal to 1. So whatever the number of moles or components present in the solution, sum of all the mole fractions supposed to be equal to 1. Again, one important application part or point to be remembered. Okay, fine. And one more note to be taken here is star. If I write it is a note. Okay, one more point to be remembered. Mole fraction is the unit which is independent of temperature. Having said that, molality is also the unit which is not depending on temperature. Once asked in KCET, okay, out of the following, the one which is independent of temperature, concentration units, if I say, then wherever volume term is not included, all those concentration units are independent of temperature. You have mass percentage which is independent of temperature. You have the mole fraction where there is no volume term, therefore it is also independent of temperature. And molality, it is mass of solvent in kg, not the volume, therefore molality is also independent of temperature. So you can take down mass percentage. What next? It is mole fraction, right? Mole fraction and S molality. Please note down, it is not molarity. Molarity depends on temperature. Molality is independent of temperature. Are independent of temperature. Independent of temperature. Is that fine? So this is about the mole fraction. Fine. Next, moving ahead, of course, we can take example for this solution containing glucose and water. Write down if you want. Calculate the mole fraction of glucose. Calculate the mole fraction of glucose. Mole fraction of, okay, let me give the mass of glucose. Mole fraction of glucose in a solution prepared by dissolving 360 gram of glucose in 864 gram of water. Yes. So I'll leave this to you to work out what you're supposed to do. Let me give the hint. Okay. So what you're supposed to do is, mass is given. You apply the concept of mole. Therefore, I told you it is application. Okay, don't expect direct formula substitution problems. Now, you know that Na, Nb, etc. So here you know what is Na, it is glucose. You are asked to calculate mole fraction of glucose itself. So X glucose is asked. I'll write it. X glucose equal to how much? For that you should know number of moles of glucose and number of moles of water, but it is not given. However, mass is given. Right? So your work is to find out Ng, that is glucose. How to do that? Mass of glucose which is given divided by molar mass of glucose formula. You have mass as 360, molar mass of glucose is 180 gram. Okay, Mg is 180 gram. From that you will get what is number of moles of glucose. What next? Water, 864 gram of water. What is the molar mass of water? H2O, 2 gram, O 16, 18 grams. So 864 by 18. With that, you can calculate next. Okay, so first work is to calculate Ng and N water. That is nothing but 864 divided by 18. You see how much it is. And here it is 360 divided by S 180 gram. So this is nothing but 2 gram. Okay, that you will get it as 48 gram. So, sorry, 48. I'm sorry, this is not gram. 2. Mole will be 2. Now, no unit for mole fraction as such. What next? Xg can be calculated with the formula Xg is equal to Ng divided by Ng plus NH2O. So obviously we can do it. So go for it, dear students. You can and you will definitely. Yes. Moving towards the last concept, that is normality. Okay, so let me write it as normality. So with that we are going to wind up this chapter, dear students. Normality is the last part to be discussed here. We have seen what is molarity. Now the one more, normality is slightly different from the molarity. However, there are many similarities in terms of calculation telling. Okay, so normality denoted by the capital letter N. Now let me give straight away the formula. Normality N is equal to number of gram equivalents. I'll write EQT, stands for equivalents. Number of gram equivalents divided by volume of solution in liter. Just you compare this with your molarity, where you had number of moles divided by volume of solution liter. Now how it is different? That number of moles replaced by number of gram equivalents. That is the change. Okay. So now how to calculate number of gram equivalents? Let me extend this particular discussion. So this is nothing but number of gram equivalents mass divided by equivalent mass or equivalent weight, you can call, okay, into volume in liter. So always used to compare so that student can understand in a better way with the molarity. What you studied about molarity? Molarity equal to N divided by volume in liter. So instead of gram equivalents, you had number of moles. How did we substituted then later modified this? Number of moles we have written as mass by molar mass into volume in liters. Do you agree? Yes. So number of moles equal to mass by molar mass, but here number of gram equivalents equal to mass by equivalent mass. That is a change. So numerator mass term will remain same in both the cases. So instead of M, here it is E. Equivalent mass is denoted by E. So only one change, dear students, in the final formula, that is normality is equal to mass. So let me write a notation, M divided by E into V in liters. So here M by M into V in liters. Did you understand? So something is there between E and M, a relation. So once you establish that, these concepts are very simple. Fine. So now ultimately normality equal to mass divided by equivalent mass into volume in liters. Now let us see how these two are connected, equivalent mass and mass. Molar mass. How to proceed ahead? Okay, the calculation very similar to molarity you can do if you know what is equivalent mass. Now whenever we say equivalent mass, the earlier concept in old edition books, you will get this, but NCERT has removed the concept of equivalent mass. Having said that, in competitive there is a trend of asking normality related questions, but it's not there in NCERT. Fine. So let us study that, what it is equivalent mass. It is definition wise, if you go equivalent mass, the mass of any substance which displaces or deposits, I can say, which displaces or which removes or which combines with, I can put that as well. So what is the mass of the substance which is going to get combined with or which is going to displace? 1 part by mass of, that means 1 gram, let us assume, okay, 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. So these 3 elements were taken as standard in order to calculate equivalent mass. Whatever the given element, how much of that element's mass is going to combine with 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine, that makes the equivalent mass of that substance. I repeat, if I take a substance as X, what is the mass of X which combines with 1 gram of hydrogen, okay, or 8 grams of oxygen or 35.5 gram of chlorine? Or if you talk about displacing, then in terms of volume you can say 1 gram of hydrogen equal to half the molar volume, that is 11.2 liters of hydrogen, and your 8 gram of oxygen is nothing but 32 actual molar mass. Now 8 gram means 1/4 of it, so 22.4, its 1/4 is 5.6 liter of oxygen, and it is the 35.5 is half of the molar mass of chlorine, so it is half of molar volume, 11.2 liters. So in terms of volume, it is 11.2 liters of hydrogen, 5.6 liters of oxygen, or 11.2 liters of chlorine. In terms of mass, 1 gram of hydrogen, 8 gram of oxygen, or it could be the 35.5 gram of chlorine. So these are the typical values to be remembered in order to calculate equivalent mass. In terms of definition, I am telling. So again, I will define equivalent mass. It is the mass of the substance which combines or displaces 1 gram of hydrogen, 8 gram of oxygen, or 30.5 gram of chlorine. So that is called as equivalent mass. So definition is fine, but how to calculate it? We will get 3 types of substances usually: acid, base, or oxidizing or reducing agent. So equivalent mass or equivalent weight formula goes according to that. So let me give those 3 formula. Okay. So equivalent mass E of acid, any acid, is equal to its molar mass divided by, for acid, basicity term will come. So molar mass divided by basicity. Okay. Whereas, see what exactly basicity? Take HCl for example. Okay, how many H plus ions are there in this? When it dissociates, H plus plus Cl minus 1. So what is the base required to neutralize it? 1, isn't it? So 1 OH minus is sufficient to neutralize 1 H plus, therefore basicity equal to 1. Take sulfuric acid H2SO4. So when it dissolves, you'll get H plus plus SO4 2 minus. Now how many H plus ions possible? 2 H plus ions. So therefore basicity equal to 2. Then the phosphoric acid, if you go on that way, you'll get basicity 1, 2, 3 respectively. Therefore equivalent mass of the acid equal to molar mass by basicity, a very important formula to be remembered. Molar mass HCl 36.5, basicity is 1. Therefore for HCl, molar mass is equal to equivalent mass. Did you get that, dear students? Sulfuric acid, molar mass of sulfuric acid is 98 gram. H2 2 gram, sulfur 32 plus oxygen 64. So 98 gram. What is its equivalent mass? Equivalent mass of sulfuric acid equal to 98 gram molar mass divided by basicity is how much? 2. So that is equal to 49 gram. Are you getting? Now here in the formula, to calculate normality of sulfuric acid you have to substitute 49 gram, but to calculate molarity you have to substitute 98 gram. That is the difference. That's all. Rest everything will remain same. Is that fine? So one formula. Similarly, equivalent mass of E of base have a formula: molar mass divided by acidity. For base, acidity term will come. So exactly similar to this. NaOH, if I take example, NaOH, which splits into or dissociate into Na plus plus OH minus. So basicity is due to OH minus ion. How many OH minus ions are there? Only one. 1 mole we can say, right? How many moles of H plus ion required? H plus is acid, right? How many acids are required to neutralize this? 1 OH minus require 1 H plus. See here similarly 1 H plus requires 1 OH minus ion. Similarly here 1 OH minus require 1 H plus ion. Therefore acidity equal to 1. So exactly similar to that of HCl. Molar mass equal to equivalent mass, molarity equal to normality. Calcium hydroxide, if I take, I'm not writing it, please understand that. Okay, calcium hydroxide, okay, I'll write it for your sake. Okay, CaOH twice. Now how many OH minus ions are there? 2. Therefore what is the acidity? 2. So for calcium hydroxide, its molar mass to be divided by 2 to get the equivalent mass, thereby the normality. So this relation to be remembered. Finally, it is about the oxidizing or reducing agent. You didn't study this, but just take down a formula. When this chapter comes, redox reaction will deal. Okay, so for oxidizing agent, equivalent mass E of OA, I will write oxidizing agent or reducing agent, it could be reducing agent, is equal to a formula: molar mass divided by change in oxidation number. Change in oxidation number. Okay, so equivalent mass of oxidizing agent or reducing agent can be calculated by taking or considering molar mass and change in oxidation number. Very, very important. I'm not going to elaborate this because it's not at all done for you. Redox reaction, once we complete that, we'll come across this formula there in that chapter and I will be doing it. Okay, so therefore these are the basic concepts of the first chapter. Heading itself is basic concepts. Hope you guys followed it. If not, please watch it again. Okay, so that make sure the concepts are clear to you. Very important basics things, and we will elaborate these ideas in the coming chapters. That's it, dear students. Thank you for watching. Thank you.